Hello, my dear friends. Uh, till of now, I have created some video without showing my face. Actually, one of my subscriber and he requested me to make video with my picture so that he may understand very well. That's why I'm here and I'm making my video with my face. And hope you understand very well. Let's start. First, minimizing my picture, making short and keep it in corner so that you can see my whole screen. And this is the uh, task of my today's program, and let me explain one by one. And today the program is about filling a tank automatically. Whenever it requires water, water will come automatically, and whenever the tank will be filled, the distribution pump, I mean the supply pump, will supply water to the required area. So let me explain first how it will work, then we will go to the program. Here I have taken two push button. One is start, one is stop. So when we will start or press start button, first the program will check whether what is the status of the tank actually. And if the tank is in lower level, I mean it exceeds the high level sensor, then the filling bulb and the filling bulb pump will start. And whenever the high level sensor will be triggered, that time filling pump and the filling bulb will be closed, and tank outlet valve and distribution pump will start. That is my program. And here is a little timing gap between filling bulb opening and filling pump running, as well as distribution pump running and tank outlet valve opening. I will show you in the program. So another part is stop. Whenever we press stop button, the whole program will be stopped. Whatever the status, whatever the state it will be in, it will stop. Okay, so first I will tell you about the ingredients of the programs. I have taken I 0.0 for start button, I 0.1 for stop button, and as you see, for high level sensor I have taken I 0.2. For low level sensor I have taken I 0.3, filling bulb, tank outlet, filling pump, distribution pump. I have taken Q 0.0, Q 0.1, Q 0.2, Q 0.3. Okay, so let's go to the program so that you understand very well. Okay, I have given a project name tank auto filling, as my program is for tank filling in auto. So let's create a project. Okay, so this is my project. I don't have any hardware, and that's why I will use the simulation. Let me show you. First I will add a new device, I mean I will take a PLC, and the PLC whatever you want you can take. In my program I'm taking 1500. Let's say first one is okay. Yes. First, we will check whether our PLC have any integrated I/O. So here, double click and check I/O tags. You see, here no I/O tags. It means our PLC doesn't contain any I/O tags. So as our program required I/O, I mean input and output. So we have to take some input and output which are digital input and digital output. So first take 16 is enough. We are using 1 2 3 4 4 input, digital input, and 4 digital output. So as the requirement, we have to take the IO. So here I see this one is DI 16. That means 16 DI we can get from it. So I'm taking it. Okay. Now we have to take DO. DO, as you saw, we used 4 DO in our design. So we have to take minimum 4 DO. Here we say DQ 8. That means 8 DO points we can use. That is enough. And also one thing I will suggest to go here and check the Ethernet address and make a subnet. Okay, and this is the default IP. I will not change it. You can change according to your requirement or according to your design. Okay, so first we will go to our program block. So here we can add a new block, and here you see here function block and functions we mainly use to create or write a program. And in my next video I will describe about the function block and functions. There is a little tricky and little difference between these two. Today I am not taking this. Today I will make my program in main block. Okay, this one is my main block. So as our design, we have to take start button I 0.0, stop button I 0.1. So let's first create this. Okay, it's better to make PLC tech fast. It will be convenient for our project. So I can keep name tank autofill. Okay, okay. So according to our design, I will take start, stop, high level sensor, low level sensor, and blah blah blah. Okay, so first start, it's automatically it's have been taken I 0.0 as I have designed. Stop, it's also taking gradually. High level sensor, high level sensor I 0.2, you see I 0.2, low level sensor I 0.3. We have already taken the 4 input as per our design. Now we will take 4 output as per our design. Filling bulb, tank outlet bulb, filling pump, distribution pump. Okay. The first one is filling bulb. Okay, so here need to change the identifier because it is outputs. So we have to take the Q, you know, as the input denotes to I and output denotes to Q. And the address we can change. Here you see 0 means the first operand and the 0.0 I will use 0.0. Okay, the next one is tank outlet valve. It's automatically taken. The fourth one is filling pump, distribution pump. Filling pump, distribution pump, distribution pump. Sorry. Okay. So we have created the PLC tags which are required in our project. Now let's go to the program. So here it will be easy. I will make if start. Then for stop, I am taking a NC contact. Stop. So whenever we will start, first the filling bulb will open, and after 5 seconds the filling pump will run. So as I told you, first the program will check the status actually. So whenever it will find the level sensor, high level sensor is not triggered, that time it will open the filling bulb first, then open filling pump. If the high level sensor is triggered, I means when the tank will be full, that time if we start, the tank outlet bulb and the distribution pump will works. So first the tank outlet bulb will open, after 5 seconds the distribution pump will start. That is the logic. So let's create like this. So as I told, whenever we pressed here, first it will open filling bulb, not filling pump, filling bulb. So make a latching here. Okay, here it will come here, copy, paste. Okay, whenever we will start, first our filling bulb will open. Okay, so after filling bulb open, first it will count 5 seconds. So we have to take a on delay timer. This is the single instance, the DB data block. It's automatically created from Siemens. Okay, so I am putting 5 seconds here. After 5 seconds, the out queue it will be on. So what we have to make on? We have to make on the filling pump. So what is the logic now? When you start, first it will open the filling bulb, and whenever the filling bulb will open, after 5 seconds the filling bulb will start running. Okay, now here is a little tricky. Whenever filling bulb open, then well, I'll describe you. Here to take another T on, T on. Here also I can give 5 seconds. I'll describe it later. Let me complete the program first. Here we will take a memory. So when it will open? It will open when the filling bulb will open and the filling bulb pump will run, when the low level sensor will be triggered. Low level. So define take global memory is okay. This is for filling pump. So I'm writing this filling pump in network 1. we will use network 2 for distribution pump. Distribution pump. Okay. So for distribution pump, we will take same as the filling pump. Start, stop. First we have to open the tank outlet valve. Tank outlet valve. So we have to write like this: tank outlet valve. Tank outlet valve. Make a latching as usual. Copy, paste. Now after opening the outlet valve, after 5 seconds, so we have to take another on delay timer. After 5 seconds, this will be triggered to the distribution pump. Distribution pump. Okay, here we can give 5 seconds, no problem. Okay, here also like this, we will take a memory for high level sensor, because when the high level sensor will be triggered, that time it will work, distribution pump will work. When the low level sensor will be triggered, that time the filling pump will be triggered. T on, 5 seconds, and here as usual we will take a memory for high level. Okay, define a tag here. It's a global memory. Okay, let's first download it. So as we are using the simulation, so we'll start the simulation first. Okay, so we have assigned a, subnet. That subnet I am using here. Start search. Okay, it found the load. Load again. We'll start our module, then finish, then download, finish. Okay, so I'm opening the simulation. I'll show you. Let's go to online. Yes, here is our simulation. Here I need to make I can give a name here, tank auto fill. Author, I can give my name, create. It's a simulation project. Okay, this is simulation project. So first I've just opened it. Let it finish. Yes, it has been opened. Simulation table. load project text. What text we have here? What text we have here? All text automatically come here. Yes. This timer text we don't need in simulation, so I'll delete all the timer text from here. Here. Okay. We will use only this. So first you see, make it smaller. Go to here and you can make it monitoring mode. So see, okay, what to keep it? Okay, let's try. Okay, when I make the start true, make this start true. Let me show again. Stop. Start again. After 5 seconds. After 5 seconds. After 5 seconds of valve opening, the pump will start. You can see. 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 The pump started. Yes, the pump started. And how long the pump will run? How long the pump will run? That is the matter. So as I told, the filling pump will run until the high level sensor has been triggered. So what is the high level sensor? High level sensor, high level sensor, high level sensor. Yes. So we'll here you will high level sensor, high level. Oh, sorry, I have made mistake. Here should be high level sensor. High levels. When high level sensor will be triggered, uh, not low. It should be memory high level. Memory high level. Memory high level. And here also need memory high level. And high level sensor. High level sensor. High level. No. Memory high level. It should be low level sensor. Sorry. It should be low level sensor. If you think little, I hope you can understand. Low level sensor. Low level sensor. It should be like this. Also here also low level sensor. Maybe the high level. Okay. Here also like low level sensor, low level memory, and low level sensor and high level sensor. Yes, should be low level. Yes, here should be high level sensor. High level sensor. And here it should be high level. It should be low level sensor. Low level sensor. Low sensor. Memory should be low level. Memory low level. Memory level. Then download. Synchronization. Load. Okay. Now we'll go to the monitoring mode and then go to the PLC simulation. First we'll make the tank. First we'll make the tank at lower level. I mean the think the tank is empty. Think the tank is empty. So when the tank will be empty, the low level sensor will be triggered. Yes, this will be triggered. And when we will start that time, this filling valve first opened. Filling valve first opened. After 5 seconds, filling pump opened. Now pump is running continuously. So water is coming to the tank, and when it will be filled with water, it will trigger high level sensor. So now it will trigger high level sensor. It will trigger high level sensor. Then outlet valve open. After 5 seconds, distribution pump will be open. Yes, you see distribution pump opened. Distribution pump first tank outlet valve opened, and after 5 seconds distribution pump opened. And the distribution pump opened remain open until the low level sensor is triggered. Low level sensor is triggered. Filling valve open. Yes. Pump off. I hope you guys understand. Actually this was a little project and very with a limitation actually, and in my future video I'll try to make with description so that you can understand the PLC programming in depth actually. So that's all for today for this video, and I hope you enjoy, and I am expecting to you to like my video and subscribe my channel so that I can be inspired to make more video. That's all for today. Thank you guys. Thank you so much.